So now we're going to make another current source. This time we're going to use 2 transistors. That way we can just take the voltage that we set to one of the transistors. We will talk about that coming up. So we'll be dealing with 5 volts directly. It's just a spec higher than 5 volts. And a 1 kilo ohm resistor, we're going to take that 5 volts, divide by 1000 ohms, 0.005 amps, 5 milliamps of current. That is pretty reliable through a wide range of loads. So to begin with, we will turn the meter off and zoom in. So at the output of the op amp, now we're going to cascade a PNP transistor and an NPN transistor. So the PNP transistor is the 2N3906 and the NPN transistor is the 2N3904. And they're in the TO92 package. Since they both start with 2N, every transistor I've ever come across that starts with 2N, whether they're PNP or NPN, their pin layout is looking at the flat side, emitter to the left, base in the middle, collector on the right. So emitter on the left, base in the middle, collector on the right. So that makes that pretty simple. Now, we're going to put the PNP transistor. So the emitter needs to be more positive than the collector because it's PNP. The NPN is the opposite. That's the more common one. And so you may hear of the opposite polarities, but that's NPN. For the PNP, the emitter is more positive. So we go there. And since we have a resistor to the emitter side of the PNP transistor, that is going to set the voltage right there that we have from the trim pot. And we're going to have current freely flowing through. So we may be able to measure that right now. So we have 5 volts, or 12 volts, I mean, at the rail. Right there, 12 volts. And at this point, now, we have the 5 volts plus the diode drop. So it's blocking a voltage at this point here. So we have the 5 volts plus the diode. It's actually, since it's a PNP transistor, the voltage is going to be slightly higher. Now we're going to take an NPN transistor and wire up the same circuit that we had in the last video. So the emitter is on the left. Now the emitter is going down, and the emitter is going where that resistor is, because again, we want to set the voltage. And there we go. I'm trying to insert that while looking at the camera, but that's the emitter down there. So my depth perception's off a little bit. So, and does not want to go in. There we go. Now we need to connect, as we saw before, this point here where the emitter of the PNP transistor and the resistor come together. That's going to give our signal. Remember, that was 5.6 volts. If you saw the last video, that's what we gave the transistor directly from the trim pot, was 5.6 volts. But this time we have the trim pot doing 5 volts, PNP transistor adding about 0.7 volts, and then the NPN transistor is going to be losing about 0.7 volts. So that voltage will end up across that resistor when we add a load. In fact, we don't even need to add a load. We can just measure. We're going to go to milliamps. We can measure the current just going through the NPN transistor from the positive rail there to the collector. Oops, I missed the resistor actually, so we got to move that over. There we go. Now you can see we have 5 milliamps of current right there, and so that's the 5 volts divided by the 1000 ohm of resistance gives us the current in amps. So 0.005, which is the same as 5 milliamps. We add an LED to the load, and it's holding 5 milliamps steady, and we can keep adding LEDs for a while. And so as we saw in the last video, we can put 3 LEDs in series and it will hold the current at 5 milliamps. And to prove they're in series, we can bypass them one at a time there. And they're in series with the transistor. So we will add the 4th one. And now it's gone down. So it held pretty steady till that 4th one. And we can even add resistance. So we'll put the resistor up there and connect to the resistor. It's 1 row away from that jumper. Try not to get that jumper. And even with the resistor, we have 5 milliamps of current. And that's going to help absorb some of the power too. So it's not a bad idea to put a resistor in there. Each component added takes a little bit off of the transistor. So the more voltage you're trying to control, the more components it helps. But the main thing is we had the same amount of current through these 3 series LEDs as the transistor alone. And so it's a current source. It holds the current to a certain level. In this case, we don't have to worry about the transistor voltage. In this case, it raises the voltage. In that case, it drops the voltage. It cancels each other out. So when it does that, you call them cascading transistors, NPN and PNP. And I use the 2N3904 and the 2N3906 because they have the same basic electrical properties, but their chemistries are reversed. So you use the opposite polarities across them and everything, but otherwise they're very closely matched. And so it's better to use closely matched transistors, but for the most part, as long as one's NPN and one's PNP, they'll probably work just fine together. So, hope you enjoyed the video. Thanks for watching. I will see you in the next video.